Okay, guys, so this is going to be free response set number 4. So let's get started. It says the rate at which a baby bird gains weight is given by this derivative right here. Okay, so for part A, it said, is the bird gaining weight faster when it weighs 40 grams or 70 grams? Explain your reasoning. Okay, so your rate is given by dB dt, so we're just going to plug in. So we're going to plug in a 40. So we get 1/5 times 100 minus 40. So 60 divided by 5 is 12. And it's in grams per day. Okay, and let's plug in a 70. Okay, so 1/5 times 100 minus 70. 100 minus 70 is 30. So 30 divided by 5 is 6 grams per day. So which one is gaining weight faster? It's this one, okay? So at 40 grams. Part B, so that's all you have to answer on that one. Part B, it says, find the second derivative in terms of B. Use d squared, the second derivative, to explain why the graph of B cannot be reasonable, okay? So if I take the second derivative, so I'm just going to take the derivative of this function up here. So I'm going to leave the 1/5 alone. Derivative of 100 is 0. The derivative of negative b is a negative dB dt. Okay, and dB dt is this right here. So it's going to be 1/5 times a negative 1/5 times 100 minus b. Okay, and so if I want to distribute that out, I get negative 4 plus 1 over 25b. Now, I want to tell you why this graph is unreasonable, okay? So the second derivative gives us inflection points and deals with the concavity. So if I set this equal to 0, get 1 over 25b is equal to 4. So b would be equal to 100, okay? So if I was to do my little number line and tell if there's inflection points, if I plug in a weight that's less than, if I plug in a weight that's less than 100, so say I plug in 20, okay? So 100 minus 20 is 80. 80 times a negative number right here is going to be negative, okay? So if I go above 100, like 105, this comes out to be a negative, and negative times a negative is a positive. Now, if we're looking at this graph, we can see that it's concave up, then it switches to concave down. And that's not right, because from 0 to 100, or from 20 to 100, sorry, is the initial weight. It should be concave down. So from okay. And part C, okay, it's a differential equation one. Okay, so let's see if I'm going to run out of room. I'm probably going to run out of room, so I'm going to do it up here. Part C. So when we solve a differential equation, so we got dB dt is equal to 1/5 times 100 minus b. Okay, we're going to get all our b terms on one side and all our other terms on the other side, and we're going to integrate. We should be really good at these by now. U sub, don't forget your u, is 100 minus b. Your du is going to be a negative dB dt. Okay, so, sorry, negative dB. We don't have the negative, so we're going to get rid of it. Okay, b is just going to function just like regular y. Okay, so this is going to integrate to a natural log, so negative natural log, absolute value of 100 minus b is equal to 1/5 t plus c. From there, we're going to plug in our initial condition. It says our initial condition is going to be 0, 20. So negative natural log of 80 is equal to 1/5 times 0 plus c. So c comes out to be negative natural log of 80. Okay. Now we're going to take that and we're going to plug it back in for our c. So we got this equation. Absolute value of 100 minus b is equal to 1/5 t minus natural log of 80. Okay, we're going to divide both sides by the negative. Okay, so we get natural log of 80 minus 1/5 t. I just wrote that in front. It's positive. Okay, we're going to e both sides. So we get absolute value of 100 minus b is equal to e to the natural log of 80 minus 1/5 t. Okay, e to the natural log power is going to cancel. It's going to be multiplication. Like that. And then we're going to solve for b. So we're going to drop the absolute values. We're going to put our plus or minus. And then when I solve for b, I should get 100 plus or minus 80 e to the negative 1/5 t is equal to b. And then I got to figure out which branch I'm going to be in. I'm going to be in the negative branch because if I plug in a 0, I get 80. And I have to get it equal to 20. So it's 100 minus 80 e to the negative 1/5 t is equal to b. Y'all should be really, really, really good at those by now, because they've pretty much been on every single homework set. Next one. It says a particle is moving along the x-axis. It says the velocity is given by that function. The acceleration is given by that next function. So part A, is the speed of the particle increasing or decreasing? Okay. So we tell that by the signs of v. So at 5.5 and 5.5. Okay, so I'm going to put those into y equals. So 2 sine of e to the x over 4 plus 1. And then y2, I'm going to do 0.5 e to the x over 4 cosine of e x over 4. Okay, I'm going to use my table. So I'm evaluating it at 5.5. So I get negative 0.4534 and negative 1.3585. Okay, so we said that if they had the same sign, the speed is increasing. Or speeding up. And I confirmed with the AP grader how they would grade that. Speed is increasing or speeding up, meaning the same thing. Okay. It says find the average velocity of the particle over the time period from 0 to 6. So average velocity, so that's average value. So it's going to be 1 over 6 times the integral from 0 to 6 of v of t dt. Okay, so we're going to use our calculator. And our velocity functions in y1, so math 9 vars, y1 comma x comma 0 comma 6. And we're going to divide it by 6, so I get 1.9493. Okay. Part C, find the total distance traveled. Total distance traveled from 0 to 6 is absolute value of v of t dt. Okay. So when we put that in the calculator, we're going to do math 9. And we need to put absolute values. So math, number, ABS, okay, y1, close parentheses, comma x, comma 0, comma 6. And we should get 12.573. Yep. And part D. It says the particle changes direction exactly once in between 0 and 6. A particle changes direction when the velocity is equal to 0. Okay? So we need to find that time. You can go ahead and delete y2. Okay, so I want to find the 0. I might have to change my window. It might be an old window. So change your window from 0 to 6. Okay, it's going to cross right here. So we do second calc, 0. I'm going to go above. And below. So I get t is equal to 5.1955. Then it says I want to find the position of the particle at that time. The way we find a position from a velocity function is we integrate. Okay, so it's super important that you write your integral setups, just like I'm doing. We've done enough of these. We should be getting the hang of this by now. Okay, so we integrate in our calculator. So we're going to do math 9 vars y1 comma x comma 0 comma 5.1955. Okay, so I get 12.1347. I'm looking for the position at this point. And my initial position is 2 from up there. So x of 5.1955 is equal to 14.1347. Okay. Next question is, so those are all calculator. This will be another calculator one. Okay, part A. It says use the data to approximate the change in temperature at T is equal to 3.5. 3.5. Okay, so 3.5 is located in between those 2 points. So we're going to say that, so this is given as h, so we'll say it's h prime of 3.5 is equal to 52 minus 60 all over 5 minus 2. So 52 minus 60 is a negative 8 over 3. And your units are going to be your y unit over your x unit, so it's degrees Celsius per minute. Okay, portion B. It says using correct units, explain the meaning of this integral right here. So anytime I see 1 over in front, that's going to be the average value. So this is going to be the average temperature from T is equal to 0 to T equals 10 minutes. Okay? And this is going to be in degrees Celsius. Sorry, I forgot to write that out. Okay, now it says, using a trapezoidal sum, estimate the average value. So we're going to say that we're going to do 1 over 10 out in front. And then we're going to do 1/2 times your delta x's. We're going to go ahead and do those real quick, like we always do on our Riemann sums. Okay? So it's going to be 1/2 times 2 times 66 plus 60 plus 1/2 times 3 times 60 plus 52 plus 1/2 times 4, 52 and 44, plus 1/2 times 1, and we're going to multiply that by 44 plus 43. Okay, so putting that in the calculator, you should get 52.95 degrees Celsius. Okay, so that's your average temperature from T is equal to 0 to T equals 10. C. It says evaluate the integral from 0 to 10 of h prime of t. Use correct units and explain the meaning to your answer. Now remember, when I take the integral of h prime, we had this on the last set, it's your first FTC, h of 10 minus h of 0. Okay, so h of 10 is 43, and h of 0 is 66. Okay. So what does this represent? This represents the change in temperature from T is equal to 0 to T equals 10 to minutes. Yep. So there wasn't really any work required there. Pretty easy. So it says at T is equal to 0, you have some biscuits that are initially at a temperature of 100 degrees Celsius and they're removed from the oven. It cools by this function right here. So it says use the given models at T is equal to 10, how much cooler are the biscuits than the T? Okay, so if I figure out the integral of this from 0 to 10, I can figure out how many degrees it cools off in that time period. Okay, so I'm going to put that into y1. So negative 13.84 e to the negative 0.173x. Quit. So math 9 vars y1 comma x comma 0 comma 10. So it's going to cool off negative 65.8172 degrees Celsius. And the initial temperature was 100 degrees. So B of 10 comes out to be 34.1828 degrees Celsius. Now, it wants to know how much cooler are the biscuits versus the T at T is equal to 10 minutes. So you're going to do 43 minus 34.1828, and you should get 8.8172 degrees Celsius. Okay? So anytime you're given a rate and you're trying to find an amount of something, you have to integrate. Okay? Make sure you understand how to do this first FTC. Okay, that's going to be all over your test, so make sure you know how to do that. Next question, solids of revolution. Should be really, really good at these too. Okay, it says, so we got to identify which graph is which. Okay, so sine's going to start here and go up this way, so g of x is on top, and f of x is on bottom. Okay, so this would be a non-calculator question. So we're going to do it non-calculator. Okay, so it says write the equation of the tangent line of f at x is equal to 1/2. So f of 1/2 we get from the graph is 1. F prime of x is going to be 24x squared. When we go to take our derivative and plug in the slope, 1/2 squared is 1/4, so you get 6. So your equation of your tangent line is y minus 1 is equal to 6 times x minus 1/2. Easy as that. Part B says find the area of R. So remember, when we find area, it's the integral from 0 to, we're going to go to 1/2, your top curve minus bottom curve. Okay, remember, just your integral setups get you points, so make sure you know how to do those. Your u here is pi x, your du is pi dx. You don't have the pi, so we got to get rid of it. So this is going to be so the integral of sine is going to be a negative cosine, so it's negative 1 over pi cosine of pi x. And we're going to go from 1/2 to 0. The integral of 8x cubed. Okay, so x to the 4th, 8 divided by 4 is 2. Okay, so we're going to plug in, we got to know our trig chart. So negative 1 over pi cosine of pi over 2 minus a negative 1 over pi cosine of 0. Okay, minus, and then we're going to plug in our 1/2. 1/2 to the 4th power is going to be 1/16, so this comes out to be 1/8. And plug in a 0, you get 0. Okay, cosine of pi over 2 is 0. Okay, negative times a negative is a positive, so cosine of 0 is 1. So this is going to be 1 over pi minus 1/8, and that's how you get your answer. Part C, it says set up but do not evaluate, and we're going to revolve it around the line y is equal to 1. Okay, we draw our ladder. Okay, there's white space, so we have to have an r big and an r little. So your r big is going to be 1 minus 8x cubed, top curve minus bottom curve. R little is going to be 1 minus sine of pi x. Okay, so we go to find our volume. Your volume's pi times the integral from 0 to 1/2 of r big squared minus r little squared. Well, that's it. We're just setting it up. Okay, next question. These are super, super important that you know how to do functions defined by integrals. Yeah, we don't got too much left to do. Yeah, we got a lot, actually. So we're about to the halfway point. Okay, so part A, it says I want to find g of negative 3. Okay, and I'm given the graph of x. So part A, g of 3, when I plug into this function right here, is going to be 2 times 3 plus the integral from 0 to 3. Sorry, g of negative 3, negative 3, negative 3. That's going to be important. G of negative 3, f of t dt. Okay, so we have a quarter circle up here with a radius of 3. So the area of a quarter circle is pi over 4 r squared. So the area of that quarter circle is going to be 9 pi over 4. So we get negative 6. Now, our integral is going from negative 3 to 0. Okay, so we have to change the sign of this because the larger limit isn't on top. Okay, so it's going to be minus 9 pi over 4. And we just leave our answer like that. Part B. Oh, we got to evaluate g prime of 3, sorry. Now, I want to evaluate g prime of 3. Negative 3. Okay, g prime of negative 3. So we take the derivative of this function. Derivative of 2x is 2. And the derivative of the integral is just f of x. Okay, so we're going to plug in. F of negative 3 is equal to 0. That comes out to be 2. Part B, it says determine the x-coordinate of a point at which g has an absolute max. Okay, so absolute maxes, we have to consider the end points and we have to consider your critical points. So that would kind of be a critical point right here. And over here. Usually if this was the derivative graph, but it's not. So don't immediately jump there. Okay, it kind of is, it kind of isn't. So g prime of x is equal to 0. That's what we have to find for our critical points. Okay, we're dealing with g. Okay, so the derivative of this is 2 plus f of x. Okay, so this is asking where is f of x equal to a negative 2. Okay, so f of x is equal to negative 2. It looks like that's 5/2. Okay, 2.5. Right? 2.5. Just like that. Okay, so x is equal to 5/2. Now, we want to prove that this is going to be a max. Okay, so when we go and do maxes, it's going to go from positive to negative once it crosses this line right here. And you can confirm that by plugging in. So say if I plug in a 0, okay? What is f of 0? F of 0 is 3. 3 plus 2 is a positive number, okay? And say I plug in a 3. F of 3 is negative. 2 plus negative 3 is a negative 1, so you're going to have a max there. There's not enough data to really do absolute max and min on this question. Their justification was since g prime of x changes sign from positive to negative at x is equal to 5/2. Therefore, the absolute max will occur there. Now, if we had the information about the endpoints for g, then we would probably be able to do a little more with that, but we don't know g of -4 and we don't know g of 3 really. So anyways, that's how we do that one. Part C. It says find all the values of x on the interval from -4 to 3 for which the graph of g has a point of inflection. Okay, so g double prime of x is equal to 0 and change a sign. Okay, so that's how we know that we have a point of inflection. Okay, so g double prime of x is going to be my second derivative. So my second derivative is going to be f prime of x. So that's going to occur where this is equal to 0. Okay, so it's going to equal to 0 up here. Okay, it's going to occur at hills and valleys on our derivative graph. So that would be an inflection point right there. So that's how we answer that. And part D, okay, it says find the average rate of change of f on the interval from -4 to 3. Okay, so average rate of change is f of b minus f of a over b minus a. F of 3 minus f of -4 all over 3 minus -4. Okay, so you should get -3 minus a -1 all over 7. So you get -2 over 7. Okay. Now, the next part of it says there is no point C in between -4 and 3 for which f prime of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Okay. Remember, mean value theorem, it has to be continuous and differentiable on your intervals. So MVT does not apply because it is not differentiable at, okay, so we know that a function is not differentiable at vertical tangents. So that's an example of vertical tangent. And it's not differentiable right here because it goes from being a positive slope to a negative slope, like that. It's a sharp peak. Okay, so it's not differentiable at x is equal to -3 and x is equal to 0. Okay, so it's important that we make sure we remember the criteria for mean value theorem. So that should be in your derivatives review packet, probably the second one or the third one. Okay, I think it might actually be in the extrema one. So whatever, it's one of those derivative packets. So make sure you look at it. Okay. Next one. Okay, it says, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. So it's modeled by dWdt is equal to 1 over 25 W minus 300 for the next 20 years. Okay, so part A says, I want to use the equation of the tangent line at t is equal to 0 to approximate the amount of waste at t is equal to 1/4. Okay, so your m tangent, we're going to plug in 1,400 for W, because at t is equal to 0, we have 1,400 tons of waste. Okay, so that's important. We get that from right here. Okay, so plugging in, that comes out to be, so 1,100 over 25. Okay, we'll just leave it like that. So if I'm going to do the equation of the tangent line, it's y minus 1,400 is equal to 1,100 over 25 times x minus 0. Okay, now I want to estimate it at t is equal to 1/4. That. So 1/4 minus 0 gives you the 1/4. Okay, so when we plug in, 25 times 4 is 100. Cancel 2 zeros. So your answer is 1,411 tons. Okay, part B. So in part B, it says, find the second derivative of this thing and determine whether it's an underestimate or overestimate. Okay, so second derivative of this is going to be 1/25. We're going to leave that alone. So we're taking the derivative of this. Derivative of W is dW dt. Derivative of 300 is 0. I forgot another 1/25. Don't forget that 1/25 on this side. Okay, so 25 times 25 is 625. Like that. Or you can leave it like this. Doesn't matter. So, when my waste is 1,411, I'm at t is equal to 1/4. That's how much waste I have. So from this, I can tell that this is going to be positive. So when your second derivative is positive, you're going to have concave up. Okay, we should know that. Now, as we've talked in previous lessons, if something's concave up and I'm drawing my tangent line, okay, so your tangent line is below the curve. Either way you go, okay? So remember, tangent's going to touch at one point, so it's below the curve. So this is going to be an underestimate. Okay? And that's how we answer that part of the question. Part C is going to be another differential equation. Okay? So it says find the particular solution. Okay, so we should be really good at these, get all our W's on one side. I'm going to go through it quickly for the sake of time, because we all should know how to do this. Integral of this goes to natural log W minus 300. Okay, we're going to plug in our initial condition of W of 0 is equal to 1400. So natural log of 1100 is equal to 1/25 times 0 plus C. That cancels. Okay, so your C comes out to be natural log of 1100. Take that, we're going to plug it back in up here. And then we got to go through and solve. Like that. Okay, so to get rid of natural log, we're going to E both sides. E to the natural log of 1100, we're going to take that 1100 and we're going to put it in front. Like that. Okay, last step is going to be drop absolute values. And we're going to put plus or minus. And then from there, we're going to add the 300. Okay, now we have to choose which branch we're going to be in. So if I plug in a 0, I have to get 1400, so I'm going to be in the plus branch. I really, really, really hope they put one of these on your AP exam because we've done a lot of them. Okay, next question. I like this question because it deals with continuity. And this will be the last question that AB you got to do. Okay, so it says prove that it's continuous at x is equal to 0. So your 3 steps of continuity. F of 0 must exist. So F of 0, it's equal to in this branch. So 1 minus 2 sine of 0. Sine of 0 is 0, so it's 1. We have to do the limit as x approaches 0 from both sides. Just like I taught you. So if I plug in a 0 from this side, I got 1. Plug in a 0 from this side. E to the 0 is 1. So that means that the limit as x approaches 0 of f of x is equal to 1. So we would say since f of 0 is equal to the limit as x approaches 0 of f of x, therefore continuous at x equals 0. Okay, part B, it says find f prime. So the derivative of a piecewise function, just a regular derivative. The derivative of sine is cosine, so this is -2 cosine of x for x is less than or equal to 0. The derivative of e is e to the u du. Like that. Now it says I want to figure out where the derivative is equal to a -3. So I'm going to set each branch equal to a -3. Okay, so I'm going to do this one first. Now, we should know that the range of cosine and sine should go in between -1 and 1. Okay, from our trig chart. Remember, our graph oscillates like that in between, so you will get no solution there. And then we're going to solve here. Divide both sides by -4. Natural log both sides. Remember, natural log of e is 1. And that's what your answer comes out to be. So that's where x is equal, that's where the derivative is equal to a -3. Okay, part C. It says I want to find the average value from -1 to 1. Okay. Now, when you find the average value of something is 1 over b minus a times the integral. So let's deal with the integral first. So it's broken up into 2 portions. So the integral of 1 minus 2 sine of x is going to go from 0 to 1. sorry, negative 1 to 0. Negative 1 to 0, that's what I meant. It's late. Plus, I want to do the integral from 0 to 1 of this portion right here. Okay, so the integral of 1 is going to be x. The integral of this is going to be positive 2 cosine of x. Okay, the integral of e is either u du. You don't have the negative 4 on front, so we're going to divide. Don't skip that step. Your u is like that. Okay, so we're going to plug in our limits. So we're going to plug in our limits here. So we get 0 plus 2 cosine of 0 minus a negative 1 plus 2 cosine of a negative 1. And then negative 1/4 e to the negative 4 minus negative 1/4 e to the 0. Okay, cosine of 0 is 1 plus 1. Okay, then minus 2 cosine of negative 1. Now, cosine of negative 1 isn't on your trig chart, so we're just going to leave it like that. Minus 1/4 e to the negative 4. E to the 0 is 1. Yeah, we're just going to leave it like that. And that's perfectly acceptable to leave it like that. That's considered algebra. Okay, AB, you're done. BC, got a couple more problems to do. Should be done within the next 10 minutes or so, hopefully. Okay, I like this question. So, it says this is f of x is equal to e to the 2x, and that's your region R. Okay, so write but do not evaluate an expression that gives the perimeter of R. Now, we haven't worked a question like this on free response, but this one deals with arc length. Okay, so if I'm doing perimeter, it's distance around the figure. So this is a distance of 1. This is a distance of k. This is a distance of e to the 2k. And then this is going to be the arc length. Okay, so remember, arc length is the integral from, we're going 0 to k, the square root of 1 plus dy dx squared. So the derivative of this is going to be 2e to the 2x squared dx. Okay, so it just wants an expression. It doesn't want you to evaluate. Part B. It says that I want to rotate it about the x-axis. Okay. Now, so if I'm rotating this region about the x-axis, there's no white space. Okay, so I don't have to do an r big or an r little. So it's just volume is equal to pi times the integral from 0 to k of e to the 2x squared dx. I'm going to leave the pi on the outside. I'm going to integrate from 0 to k of e to the 4x dx. A power to a power, you multiply the exponents. Okay? E to the u du, you don't have your u. Your u is 4x, your du is 4 dx. Okay, so I divide by 4. So this is pi over 4 e to the 4x. And I'm evaluating it from 0 to k. Okay, so I plug in the top limit. And I'll plug in the bottom limit. Okay, e to the 0 is just 1. So that's what your final answer looks like. Okay, part C, it says the volume found in part B changes as K changes. Okay, so what I'm going to do is, this is kind of like a related rates question because more than one thing are going to be changing the problem. The volume is going to be changing and your K is going to be changing. So for part C, dv dt is the rate of change. The derivative of this is going to be pi e to the 4k dk dt, and the derivative of pi over 4 is just going to be 0. Okay. So dv dt is going to be what we're looking for. Your e to the 4, your k is 1/2, and dk dt is 1/3. So this is pi over 3 e squared. Okay, so that's just a little bit different type of question. I like this question because the arc length. For 2020, we haven't had to do any arc length really because we took out the parametric stuff isn't going to be tested. So, you know, we lose a little bit of problems with that. But this is really good that we know how to do this arc length. Okay, so that's in your partial fractions, integration by parts set. Okay, so, and our favorite Taylor series and all that stuff to do here. Okay, so it says f of x is given as sine of x squared plus cosine of x, and you're given some graph up here. We're not going to be using this graph in this question. I deleted a part of the question because it's not on this year's free response, so just keep that in mind. So for part A, it says we want to write the first 4 non-zero terms for sine of x, about x is equal to 0. So when we do Taylor series, we take our first few derivatives. Now I'm going to write kind of small because we're going to have a lot of derivatives. And hopefully we're getting the hang of these Taylor series ones a little bit better than we have before. It's almost a guarantee that this is going to be on your AP test. Okay, so remember sine of 0 is 0, so we got to get 4 cosine terms in here. Okay, so when we go to plug in, we're going to plug in about 0. Sine of 0 is 0, cosine of 0 is 1, 0. Cosine of 0 is 1, so this is -1. So it's going to alternate. 1, 2, 3. This is very tedious. But this isn't a hard question, so. Okay, so I got my first 4 terms. So for sine of x, 0, we're not going to write that 1, so this is going to be 1 times, so 1 times x, so it's just x, minus 1 over 3 factorial, x cubed, plus 1 over 5 factorial, x to the 5th, because that's my next one, and then minus 1 over 7, x to the 7th, x, 7 factorial, sorry. Okay, and if you want to factorial it out, be my guest. Okay, now it says we need to evaluate for sine of x squared. Now make sure you pay attention that it's not asking you for the general term. Okay, so sine of x squared, we're just going to take an x squared and we're going to plug it in everywhere there's an x. So we should get x to the 6th plus 120, x to the 10th minus 1 over 50, 40, x to the 14th. So remember, a power to a power, when I raise a power to a power, we're multiplying. Okay, almost done. Part B. It says, write the first 4 non-zero terms for cosine of x. Okay, and then use it, so use this part combine with that to write the first four non-zero terms. Remember, f of x is equal to this up here. Okay, so cosine of x. Here, I'm going to write my first few derivatives. Let's call it g of x. Okay, so g of x is equal to cosine of x. G prime of x is equal to negative sine of x. G double prime of x is equal to negative cosine of x. G triple prime is going to be sine of x. Fourth derivative is going to be cosine x. G of fifth. Negative sine of x. G to the sixth is going to be negative cosine of x. So remember, cosine of 0 is going to be 1. So we need 4 cosine terms in here to get 4 non-zero terms. Okay, so g of 0 is 1. G prime of 0 is 0. G double prime of 0 is negative 1. G triple prime of 0 is 0. So sine of 0 is 0. Cosine of 0 is 1. G to the fifth of 0 is 0. G to the sixth of 0 is negative 1. So cosine of x, if I'm going to write my Taylor series with the first 4 terms, is going to be 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the 4th. So I'm going to write here. And then minus 1 over 6 factorial x to the 6th. So minus 1/2 x squared plus 1 over 4 factorial is 24 x to the 4th. I think it's 720. Let me double check that real quick. 6 math. Yeah, it's 720. 1 over 720. Okay, now the final part of this answer for part B says that you want to combine these terms and we want to go to the 4th power. Okay, so sine of x squared plus cosine of x. First 4 non-zero terms. Okay, so first term is going to be a 1. And then I have an x squared term here, an x squared term here. So x squared minus 1/2 x squared is going to be positive 1/2 x squared. I have an x to the 4th term. And then I have x to the 6 terms right here, and that's going to be it. So when you combine those together, if you want to use your calculator, that's my 4th degree Taylor polynomial right there. Okay, so I don't even worry about these terms because, this term and this term because those aren't the first 4 non-zero terms. Okay, part C, super easy. It says find the value of the 6th derivative of 0. Okay, remember how we do this. 6th derivative of 0 over 6 factorial is equal to the coefficient of the 6th degree term. Okay, so that's our expression right there. This is 720. So we're just going to multiply it to the other side. So the 6th derivative at 0 is equal to a negative 121. And that's it. Sorry this was a long video, guys, but it needs to be done. So if you have any questions or anything, feel free to reach out. Thanks. Bye.